Okay, so these are the answers for the fall of 24 Rock and Mineral ID exam. So we'll start here with the minerals first. So we're going to start with minerals. Make sure we got this camera adjusted to the or that way I can zoom in a little bit. Okay, so this very first sample, this is known as lodestone. It's actually a piece of magnetite. It is magnetic. There's a magnet sticking right there on the side of it. So this is magnetite full of iron. This is the most heaviest concentration of iron of any mineral, and that's why it's magnetic, and it's called magnetite. Sample number 2. This is one of the mica minerals. This particular mica is black in color. We call this biotite. There's another one that we saw called muscovite. So muscovite is kind of a silver color. The biotite is black in color. It has a little bit of iron in it. This is actually, they use this to make computer chips. So number 2 is muscovite. Number 3. Maybe I should go to the other side of the table here. So number 3, this is almost translucent, not quite transparent. This is cubic, so it has very good cleavage. Cubic cleavage. And this is a piece of halite. So halite basically is salt. Number 4. This is fool's gold, or pyrite is the official name. FeS2 is the chemical formula, so there's absolutely no gold in here. It's iron and sulfur. The sulfur is a yellow mineral, and the iron is dark gray. So the combination of the dark gray and the yellow sulfur make for a gold metallic mineral called pyrite. High density, very heavy. Number 5, this mineral has excellent cleavage. This is actually a piece of potassium feldspar, or known as K-spar. We like to call it K-spar because K is the symbol for potassium. And so we call this has great cleavage, very vitreous luster, very shiny, kind of a salmon pink color. Definitely has the great cubic cleavage. So this has 2 good sides of cleavage. 2 directions of cleavage, I should say. And so this is potassium feldspar. Number 6, tectosilicate. This is basically a piece of quartz. So quartz is one of the highest silicates. And so the only thing I tell you about quartz has a hardness of 7. Very hard. Scratches glass real easily. Has this nice little hexagonal prism structure to it. So these prisms are actually terminated by pyramids. So the termination is pyramids. And this is hexagonal quartz. Number 7, probably the heaviest and the most compact of all of our minerals. This is galena. The chemical formula is PBS, so it's lead and sulfur, PBS. And this is galena, very shiny, vitreous luster, cubic. This mineral has cubic cleavage, very high density, very heavy. Very vitreous luster. Some of this will actually have silver in it, and we call it argentiferous galena. But this is just mostly just galena. All right, number 8. This mineral reacts to acid. So any mineral that reacts to acid, we have this little placard right here. It says reacts to hydrochloric acid. So number 8 reacts to hydrochloric acid. This is 6120 cleavage. This is calcite. Calcite's fairly soft. It will not scratch glass, but it reacts real readily with acid. So you put 10% hydrochloric acid on it, and it bubbles right up. So that is number 8. Now going over to number 9 here. This mineral has a unique feature in it. It has striations in it. I don't know if we can see these in the light or not. Nice little straight lines, almost like it was cut with a laser. Striations are common in plagioclase. This is a typical rock-forming mineral, plagioclase. Number 10, rose quartz. Pretty neat, nice pink quartz, very glass-looking. Quartz generally is glassy. Hardness of 7, scratches glass real easily. And this is quartz, rose quartz. Now we're going to go to the rocks. The first group of rocks we're going to look at are going to be the igneous rocks. And the first igneous rock, its composition is intermediate. That means it consists of iron-rich minerals and quartz-rich minerals. This is what we call the diorite. So diorite basically is half and half black and half white. So it's probably much an equal distribution between the white plagioclase and the black amphibole. So there's two minerals that make up this rock, and that is the black amphibole and the white plagioclase. Number 11, diorite. 12 looks kind of similar, but it's very fine grain. This is a typical granite. It's just a plain granite. And what gives the granite away is that it's full of this silver shiny mineral. And I'm trying to move the camera around a little bit so we can see some of the glitter. And that glittery stuff in there is actually muscovite. So this rock is full of muscovite. This is a typical granite. So number 12, granite. Number 13, pretty neat looking piece of obsidian. This is mahogany obsidian. So mahogany obsidian has the brown and the black mixed together. Pretty neat stuff. This actually came from Utah. Utah seems to have the best mahogany obsidian. Native Americans would actually trade this in the Hohokam and the empires. They would actually go, they actually found the obsidian that came out of Utah all the way down in Mexico. So the Native Americans, 10,000 years ago, the Anasazis, traded this obsidian because this was prized obsidian to have. So that's mahogany obsidian. Number 14 has a unique texture to it. This texture is called porphyritic. So this is called a porphyritic granite. And the reason we call it porphyritic is because of the large phenocryst, the pink mineral, the potassium feldspar. It's larger than the other minerals. And that's why we call this texture porphyritic. It's felsic. It's rich in quartz. Number 15, a rock that's not felsic, that's not rich in quartz, is this here. This is a piece of gabbro. So gabbro, the main component of this rock is all plagioclase, dark plagioclase. And you can see the little bit of a glitter there. So this is all full of plagioclase. This is basically a gabbro. Mafic igneous rock rich in iron, gabbro. Now I have to go across the room here. We'll continue with the igneous rocks. So when it comes to this igneous rock here, I want you to look at primarily just the green part of this rock. This rock here, the green part is called a dunite. This is actually peridotite dunite. So it's a volcanic rock that forms extrusively above the ground. Hawaii has a lot of this. This is very high temperature mineral. This is the highest, this is what we call ultramafic. So ultramafic rocks are green. They're so rich in iron and magnesium that they produce this green color. And the main mineral that makes this green color is olivine, but the rock is called a dunite. The next rock, number 17. This rock here is a granite pegmatite. So pegmatites, we would call them pegmatites because they have very large distribution of minerals. They have big minerals. These minerals are all large. So it consists mostly of potassium feldspar, quartz, and muscovite. So the muscovite, the silver looking mica in there, that's the muscovite. And this is a granite pegmatite. Number 18 is just a red granite. This is a red granite. This comes from Upper St. Michigan. It's part of the Canadian Shield. These are very old rocks, about 3.8 billion years old. The oldest rocks of the North American continent, basically, except for the stuff that came from Australia. But that's a different story. So this is a piece of red granite. And the red color in there is due to potassium feldspar that's pretty rich in iron. Number 19. This is what we call vesicular basalt or scoria. So it has holes in it, lots of holes in it, air holes. So the air, what escaped out of this rock was mostly carbon dioxide and sulfur dioxide. So this is a fairly volatile volcanic rock, lots of gases. So number 19 is a piece of vesicular basalt. And then we end the igneous rocks at number 20 with another piece of obsidian. This is black obsidian. This actually came from Mono Lake, in the Mono Lakes area, not actually Mono Lake itself. Very vitreous luster, has a nice conchoidal fracture right there. You can see the circular half-moon shape of the conchoidal fracture. Very vitreous luster, very glassy, very black piece of obsidian. And this is a felsic rock, believe it or not. Felsic meaning quartz rich, because this is probably about 98% quartz. Just a small amount of iron got in there to make this rock turn black. So this is the black obsidian. Now we go to sedimentary rocks. Sedimentary rocks, a little bit different class of rock. These rocks are particles and pieces of other rocks that have weathered out. Number 21, when we have rounded grains that come together, and these are pretty well rounded, this is what we call a conglomerate. So conglomerates are rounded, gravel-sized material that's rounded, all cemented together, as opposed to the stuff that's angular, and this is the breccia. So breccias are more angular, and conglomerates are more rounded. So that's the difference between the conglomerate and the breccia. Number 23, one of my favorite rocks, phospholiferous limestone. So you can actually see the different fossils in this limestone. You can see shell-like fragments. There's some turbines now. There's some turbines in there. Different fossils. So we have a couple of sample of these out here. So this is phospholiferous limestone. And then number 24, this is what we call hematitic sandstone. So hematitic because of the red color. What actually stained this rock red is a mineral, an iron oxide mineral called hematite. So hematite is an iron oxide, and so we call this hematitic sandstone. The other component that makes this rock is mostly quartz sand. Number 25, kind of a unique rock here. This is a very dirty sandstone, and it's full of potassium feldspar or K-spar. These little pieces in there are actually K-spar. You can see the K-spar in this quite well. This is a poorly sorted sandstone. Everything's not the same size, unlike a quartz sandstone where everything is the same size, and we call those well sorted. So this is a very dirty sandstone. This is an arcosic sandstone. Number 26, this is a common piece of shell. You can call it mudstone, siltstone, claystone, shell. It's all the same shell. So this is kind of a green color shell. It has nice rock cleavage. Nice flat layers. Number 27. Now this is definitely a well-sorted sandstone. So everything here is the same size. This is quartz sand. Very fine grain. All the grains are the same size, so we call this well sorted. And this is a piece of quartz sandstone. Number 28, you loved it as a kid. This is chalk. So chalk is actually formed in a billabong or a lagoon. They formed in little lagoons, warm water. Microorganisms make up this piece of chalk. It does react to hydrochloric acid. So anything that reacts to hydrochloric acid is going to have calcite in it. And this certainly has calcite in it. Number 28. Actually 29, sorry about that. So number 29, this is a piece of bituminous coal. So bituminous coal basically is the dirty coal. Has lots of sulfates in it. The anthracite coal, the metamorphic coal, the sulfates are driven out, and basically you're left with almost pure carbon. So this is the bituminous coal, very soft, very dirty coal. We burn a lot of this in the United States and in China. And then the last of the sedimentary rocks, number 30. This is a piece of quartz. This is sedimentary variety of quartz. It forms in deep water solutions. This is what we call chert. There's a red variety called jasper and a black variety called flint. This is actually chert. So we just call the white version of quartz chert, number 30. We now move to metamorphic rocks. So this rock here is a nice flat piece of slate. This is Fred Flintstone's boss, Mr. Slate. So that's slate. This is the low-grade metamorphic rock. It looks much like a shell. It has the same characteristics of a shell, but it's been slightly baked, more compacted into a rock we call slate. The next grade of metamorphism is called a phyllite. So phylites have a little bit of a shine to them, a little bit of a wavy texture. So this is a higher degree of metamorphism than the slate. This is called a phyllite. And then the next level of metamorphism is number 33 here. This is called a schist. This schist is full of micas. This is actually a mica schist. The little red things in there, those little bumpy things, those are actually garnets. Very crude garnets. Those are garnets in there. And garnet is an index mineral for schist. So this is a piece of schist. Again, we have to trek across the room and finish up the metamorphic rock section. Number 34, I asked you specifically, what was the main mineral that made up this rock? This rock is full of 100% to maybe only 98% amphibole. So amphibole is a rock-forming mineral. It's an iron-rich mineral, and this rock is full of amphibole, so we call the rock amphibolite. Fine grain amphiboles in there. We call this rock amphibolite. Number 35 reacts to acid. So about the only metamorphic rock that reacts to acid is going to be marble. So its parent rock was a limestone. That limestone was subject to heat and pressure, metamorphosed, and formed into a marble. Reacts to acid readily, real easily. 36. The opposite of the marble. Looks very similar to marble, but far more compact, but consists of quartz. And this is going to be a piece of quartzite. So you take quartz sandstone, you put it under heat and pressure, and this turns into a rock called quartzite. So here, the quartz grains became fused together. Very hard rock, quartzite. 37, the green color should give this away. This is actually a piece of green stone. So this is green stone, number 37. It is considered a foliated rock, even though this one has no foliation, no layering to it whatsoever. Green stone. 38. Its parent rock was a conglomerate, or a breccia. So the rock is going to become a metaconglomerate. So this is a conglomerate, or a breccia, that was subject to heat and pressure, and formed into a metaconglomerate. 39. This rock has nice layering to it. It has compositional banding. This is what we call a gneiss. This is the highest degree of metamorphism. It's a gneiss rock. The two minerals that are in this rock consist of the black one is amphibole, and the white is plagioclase. You can see definitely the compositional banding, how the black minerals and the white minerals line themselves up to form this compositional banding. And our last rock, number 40. This reacts to acid again. A little bit more crude, a little bit more coarse, I should say, actually. This is a nice piece of marble. This actually came from the Marble Mountains out in San Bernardino County near Amboy Crater. So I actually picked this piece up on a trip, and this is a nice piece of marble. It reacts to acid, as all marbles do. And the reason that marble reacts to acid because it contains calcite. So any rock or mineral that contains calcite or has calcite as the main component will react to acid. So when I give you these nice little placards here that say reacts to acid, that tells you it reacts to acid. So this ends the 2024 Fall Rock and Mineral ID Extra Credit Test. So hopefully this will be useful for you in your studies. And we'll see you guys in class.